All right, in this video, we're going to talk about section 13-3, dealing with the Pythagorean theorem, distance formula, and equation of a circle. And in this section, we'll use the Pythagorean theorem to find the length of a missing side of a right triangle, use the converse of the Pythagorean theorem to determine if three lengths of sides form a right triangle, and determine the measure of sides in special right triangles. Also calculate the distance between 2 points using the distance formula. Identify the center and radius of a circle written in standard form, and write the standard form of the equation of a circle. So pretty much just like going to be discussed in this video for section 13-3. So first of all, we need to talk about a right triangle. If you recall in a previous video that I did, a right triangle is a triangle that has a right angle indicated by this red box that you see at the vertex of that triangle. Okay, now in a right triangle, we have two legs, which are labeled A and B, as you can see here. The longest side of this right triangle, or the side opposite the right angle, so this is the right angle here, then the side opposite that would be the hypotenuse, which is labeled as C. And the hypotenuse is always going to be the longest side of that right triangle. And of course, A and B are legs. Now, let me introduce you to the Pythagorean theorem. Now, this is only for a right triangle. If you are given a right triangle with legs A and B and the hypotenuse C, then this is our Pythagorean theorem. C squared is equal to A squared plus B squared. In other words, if you were to write this out in words, the square of the hypotenuse is equal to the sum of the squares of the other two legs in that right triangle. Okay. So when you find the hypotenuse, you're going to square the leg, and then square the second leg, add them together. Then to find out what the hypotenuse is, since this is C squared, you have to take the square root on both sides to find out what C is. Okay. Now let's look at some examples of just this. Okay. And in this case, I'm going to have to do these problems on a separate sheet of paper. All right, so for homework example number 1, you're going to use the Pythagorean theorem to find X and Y in each of the following. And we're going to complete parts A through F below. So here we have a right triangle, as you can see here. And I'm going to move this over to the side so that you can see what I'm going to be doing here. And this is part A. So here we got a hypotenuse of 5. That's the side that's opposite that right angle. And one of the legs is 4. We need to find out what the other leg is, which is what X is. So here we're finding out what X is. So here we're going to be using this. And it doesn't matter which way you write this, by the way. C squared is equal to A squared plus B squared. Or you can write as A squared plus B squared is equal to C squared. It doesn't matter, it's the same thing. All right, so now let's identify what C is. Here's C right here, which is your hypotenuse. That has a length of 5. So it's going to be 5, and that's squared. And that's equal to, I'm going to let this leg that's shorter than the other, this one will be A, which is labeled as X. So it'll be X, then that's going to be squared, plus the other leg has a length of 4, so it'll be 4 squared. Okay. Now let's simplify this. 5 squared is 5 times 5, that's 25. That's equal to x squared plus 4 squared is 4 times 4, that's 16. So I got x squared plus 16 is equal to 25. Now to get x squared by itself, we're adding 16. So the opposite of that would be to subtract 16 on both sides. So that means x squared is equal to 16 from 25 will give you 9. Now, we've only solved for x squared. We want to solve for x. The opposite of squaring anything would be to take the square root on both sides of this equation. So the square root of x squared is x. And then we find out what the square root of 9 is by finding out what number times itself gives me 9. And it has to be 3. Okay. Now we're only using the positive values here because lengths cannot be negative. So in that problem there, for part A, x then will be equal to 3. So that's the answer to part A. All right, now this is part B right here. Here we're finding the hypotenuse. We're solving for x this time. We're finding the hypotenuse here. We know what the two legs are. This leg is 30 and the other leg is 16. So in this case here, I'll do part B over here. The Pythagorean theorem, we write that down as c squared is equal to a squared plus b squared. Now, of course, your c is your hypotenuse, and that's labeled as x, which is what we're trying to find. So I'm going to substitute the c with the x, so the x squared is equal to, I'm going to let this side be length a, which is 30. So it'll be 30, and that's going to be squared, plus the b, which is this other leg right here, that's 16. So it'd be 16. And then that's going to be squared. And then we simplify this, that x will be squared, it'll be x squared is equal to 30 squared, which is 30 times 30, which is 900, plus 16 squared is 16 times 16. That would give you 256. And then if I add 90 and 256 together, this will give you 1156. And then to solve for x, I'm squaring it. So the opposite of that would be to take the square root on both sides of this equation. So that way I will have x by itself. And then that's going to be equal to, now if I do this on the calculator, square root of 1156, I will end up with 34. So that means x would be equal to 34. So the length here, which is my hypotenuse, would be 34. Okay. All right, this is part C. And that's going to be this triangle right here that I'm trying to find this, the length of that leg right here. Okay. Now in this case here, I see that this length is going to be 9. And I might need to highlight that in green. Okay. That's going to be this side, this part right here. That has a length of 9. And this has a length of 15. That's the hypotenuse. I'm going to find the length of this leg right here. I'm highlighting the one that's in green. All right. So now in part C, that's going to be c squared is equal to a squared plus b squared. It's still a right triangle. So we're going to find the length of this leg right here, which is labeled as x. All right, the c is your hypotenuse. That's your 15. So that's 15 squared. And that's equal to, I'm going to let this be a, which is 9. So it'll be 9 squared plus the b, I'm going to let that be x. So it'll be x squared. And then we simplify. 15 squared is 15 times 15. That would be 225. And that's equal to 9 squared, or 9 times 9, that's 81, plus x, and that's going to be squared. Now to get x squared by itself, I'm adding 81. So I need to subtract 81 on both sides of this equation. So that means this is going to be 144. That's equal to x squared. And then the opposite of squaring something would be to take the square root on both sides. So that means this will be x is equal to, the square root of 144 is 12. So this x, which is this length here, or the altitude, as it's called in a triangle, where it's perpendicular to the base, that will be 12. Okay. Now take a look at part D. Now in the homework, you'll be asked to type the exact answer using radicals as needed, type an expression using s as the variable, and use integers or fractions for any numbers in the expression. So here we have an equilateral triangle here. Okay, so let me move this over to the side and just focus on that equilateral triangle. So this is part D. Now, if you recall, in the equilateral triangle, by definition, an equilateral triangle is a triangle where all three sides have the same length. So if this is S, then that means this side here is also S. And this side here is also S. Okay. Now, this altitude, or this height, separates this side into two equal parts here. Okay. So if I take half of S, the length of this side that I'm going to mark in red, that's going to be 1/2 S. Okay, so that length that's marked in red is 1/2 S. And this length right here is what I'm trying to find. And I know what S is right here. That's the hypotenuse. All right, so here we're going to use c squared is equal to a squared plus b squared. The hypotenuse, which is c, that's this s right here. So this will be s, and that's going to be squared. That's equal to, this will be a, but that represents 1/2 the length of s. So this will be 1/2 s, and that's squared, plus the b, that's going to be your x. Now here we're solving for x. Okay. So s would just, s and u squared would be s squared. Now if I square 1/2, I have to square the numerator and square the denominator. Square the 1, you're going to get a 1. Square the 2, you'll get 4. And then s will be squared plus x squared. So I have s squared is equal to 1/4 s squared plus x squared. Now I need to get x squared by itself. I'm adding 1/4 to it. So that means I need to subtract 1/4 s squared. I'm sorry, I need to subtract 1/4 s squared, not just the 1/4. Now the s squared has a 1 in it, so you have to think of 1 minus 1/4. 1 minus 1/4. That's actually 3/4. s squared. And that's equal to x squared. Now we want to solve for x. We're squaring it. So the opposite of that would be to take the square root on both sides. And I have to take the square root of the entire fraction. So the square root of x squared, the square root of x squared is x. Now, let's think about this for a moment. We can take the square root of s squared. That would be an s. So that s will be on the outside. We cannot take the square root of 3 and get a whole number from it. So that 3 remains underneath the radical, but we can take the square root of 4, which is 2. So here, if I was to clean this up just a little bit, x would be equal to s over 2 times the square root of 3. And that would be what x is. That's what we're looking for, the length of this side right here. Okay. All right, now let's look at part E. Here we're going to solve for both x and y. Okay, notice that x is this length on the top of this square, and the y is going to be that diagonal right here. Okay, and notice we have a cube. We have a length and a width and a height. They all equal 3. So here we have the cube here. All right, now let's focus on solving for x. And then we'll solve for y. Okay, now x is the one that's on the top of that cube. Here's x right here. Now, I know something about the cube right here because all the lengths have to be equal. So that means if I know that this is 3, and that's 3, in a cube, all the lengths of all the sides are equal. So this must be 3, and this side right here must also be 3. And in this case, your x is your hypotenuse. So here we can find the hypotenuse, or x in this case, by using c squared is equal to a squared plus b squared. And then we just substitute the length of this side. Well, c squared is what I'm trying to find. Or better yet, that hypotenuse is x. So, and c is your hypotenuse. So let's substitute that c with the x. And then that's going to be squared equals 3 squared plus another 3 squared. So x and we squared will be x squared. 3 squared will be 9, and then plus another 9. 9 squared will be 18. And then to solve for x, we have to take the square root on both sides. There should be x squared underneath that radical. So the square root of x squared will be x. Now, this will be equal to, now we're going to have to think about this one because we can't give an answer in terms of a decimal. What that means here is this. We need to use that table of powers. That's going to help us determine what the square root of 18 is. Now, you're going to have to think about this for a moment because we need the largest perfect square that would go into 18. Okay, now if you remember that table of powers, okay, now let me go ahead and pull this up. And here is that table of powers here. Now we're only going to look under the n squared column. So we need the largest perfect square that goes into 18 evenly. But 16 won't go into 18, but 9 will. 9 goes into 18 evenly 2 times. Okay, so let's use 9 times 2. So here we're going to have underneath this radical the square root of 9 times 2. And then we can take the square root of 9, which is 3, that goes on the outside. We can't take the square root of 2, so that stays underneath the radical. Okay, so here we're going to have 3 square root of 2 for this hypotenuse right here, which is what x is. Okay, now we're going to use that answer to find out what this length down here is, that y. And here y is another hypotenuse. I'm going to join this length of x with this length of this edge right here, that cube, which also has a length of 3. So in this case here, I know what x is, and I know what this length is. I can find out what y is. Again, that's a hypotenuse. So here I'm going to use, and I might need to move this over just a little bit, the same Pythagorean theorem, c squared is equal to a squared plus b squared. Now this right here is your x. We've already found out what x is. That's 3 square roots of 2. So now this hypotenuse is your y. So I'm going to substitute the c with the y, so it'll be y squared. And then that's equal to, that a is going to be 3 square roots of 2, and that's squared, plus b, which is 3, and that's going to be squared. Now the y mu squared will be y squared, and equals to 3 squared is 3 times 3, which is 9. Now, the square root of 2, and you turn around and square it, what's going to happen here is it will eliminate the square root symbol, leaving you with what's underneath it. That will be 2. And then plus 9. Now let's multiply 9 times 2, which is 18, plus 9. And then add 18 plus 9, that will give us 27. So here I have y squared is equal to 27. And now to solve for y, we just take the square root on both sides. So here y is equal to, now again, 27 is not a perfect square. So that tells me I need to look for the largest perfect square that would go into 27 evenly. And I can tell you 16 won't go into 27, and 9 will go into 27 evenly. So we're going to use 9 times what number gives me 27? Has to be 3. So I can write that as y is equal to the square root of 9 times 3. Now I can take the square root of 9, which is 3, and then bring down square root of 3 because 3 is not a perfect square. So that's what y is equal to. That's the length of this hypotenuse here in this cube. Y is equal to the 3 times the square root of 3. So as you can see here, I had to use the length of x's. I had to find out what x is first before I can find out what y is. Okay. And here's another example of just that. Okay, here we got this rectangular prism at the bottom, right here on the side. Now, we want to find out what x and y is, and we're going to use exact answers using radicals whenever needed. So here we got a rectangular prism here. Let's look at this top portion of that prism. That is a right triangle, by the way. Okay. Now, we're told that this length here is 12 and this height is 7. This length down here is 20. Well, if that's the case, if this is 20 going this way, then what's on top has this part right here, since it's a rectangle and opposite sides are equal in measure, this has to be 20. And if that's 20, then this side right up here at the very top, which I'm going to highlight in red, because this is the right triangle that I'm going to be dealing with, that side has to be 20. That side right there has to be 20. Now we can find this side right here, which is our hypotenuse here, which is x. Using the Pythagorean theorem, we're going to use this. C squared is equal to a squared plus b squared. And our c is the hypotenuse, which is in this case labeled as x. So it'll be x, and that's squared, equals to a, that's 12, and that's squared, plus b, in this case, it's going to be 20. And that 2 is going to be squared. Well, x and u squared will be x squared. 12 times 12 is 144, plus 20 squared, 20 times 20, that would be 400. And then x squared would be 144 plus 40 will be 544. And then to solve for x, we take the square root on both sides of this equation. This will give us x equaling to, now 544 is not a perfect square. Okay, so here we're going to have to think about this for a moment. So let me bring back that table. As you can see here, we need the largest perfect square that goes into 544. Okay. Now this table goes all the way up to 400. Okay. Now this table was previously introduced in a video in section, I believe section 7-5. Okay. And it should be in one of the notes given to you. So check for that. Let's see. Okay, now I know 544 would not be divisible by 400. And nor will 544 be divisible by 361. 544 is not divisible by 324. Nor is it divisible by 289. I'm starting from the bottom on that n squared column and working up to the top. Let's see, 544 is not divisible by, let's see if it's divisible by 256. No. 544 is not, let's see, 544 divisible by 225, definitely not. Let's see, 544 divisible by 196, nope. And then 544 is divisible by 169. How about 544 being divisible by 144? No. 544 divisible by 121. No. Well, I know 544 can't be divisible by 100. Let's try 544 being divisible by 81. No. 544 divisible by 64. No. 544 divisible by 49. No. 544 divisible by 36. About 544, not, it can't be divisible by 25. I'm going to try 16. It is, finally. Okay. And 544 divides 16, that would be 34. Okay. So here, 16 is a perfect square. That's the largest perfect square that goes into 544. And it goes into 544 34 times. So sometimes you gotta, you know, try something here and just play around with that table that I just showed you in this video under the n squared column. All right, the square root of 16 will be 4, and we can't take the square root of 34 to get a whole number. So it'll just have to remain as 4 square roots of 34. 4 square roots of 34. And now we're going to find out what y is. Okay, now the triangle that I'm going to focus on here, and I'm going to outline this in green. That's going to be this hypotenuse, the length of this side, and the length of x. Okay. So here, x we know is 4 square roots of 34. This length here is 7. Y is what we're trying to find. And y, of course, is the hypotenuse. So again, we're going to use c squared is equal to a squared plus b squared. And in this case here, c squared, that's your hypotenuse, that's your y. So it'll be y squared equaling to a. That's going to be that x squared, or 4 square roots of 34. That's going to be squared, by the way, plus b, which was 7. That's squared. The 4 square roots of 34, that's this x, and this right here is 7. And now we're going to go ahead and simplify this. The y in u squared will be y squared. 4 squared is 4 times 4, which is 16, times the square root of 34. You turn around and square it, it's going to be what's underneath that radical. So just be 16 times 34 plus 7 squared is 49. That's 7 times 7. So now you got y squared is equal to 16 times 34 was 544 plus 49. So y squared would be 593. And then if you take the square root on both sides to solve for y, so it'd be y is equal to, and we're going to have to leave that as the square root of 593 because there is no perfect square that would give us 593. There's no factor of 593 that would give us a perfect square. So we leave that as a radical. Y is equal to the square root of 593. Okay. And so all of that was homework example number 1 that I just did. Okay, now let's look at this real life problem using the Pythagorean theorem. A 17-foot ladder is leaning against a wall, and the wall is perpendicular to the ground. The base of the ladder is 11 feet from the wall. How high above the ground is the top of the ladder? So in this case here, we're going to need to pretty much draw a figure, which will help us understand that problem. All right, let's say that there is a wall right here. Now, excuse me. Let's say that there's a 17-foot ladder leaning against the wall. So here's a ladder, and keep in mind, my drawing's not the best. It's 17 feet, so that length is 17. Now the base of the ladder is 11 feet from the wall. So here's the base of the ladder. And here's that wall right here. That length is 11 feet. So this is 17 feet. This is 11 feet. Now I want to find out how high above the ground is the top of the ladder. In other words, from this distance from the top of the ladder, from the base of the ground, I want to find out what this length is. And I'm going to label that as X. That's the height that I'm looking for. This does form a right triangle, so we can use the Pythagorean theorem. And the Pythagorean theorem is this: c squared is equal to a squared plus b squared. Okay. I'm going to let this base, the distance from the base of the ladder to the wall, be 11 feet. That's going to be my a squared. Actually, the c is the length of that ladder. It's 17. So 17 squared equals to 11 squared plus b squared. Well, b is going to be x, which is what I'm trying to find. Okay. And maybe this will help. This right here will be A, this is B, and the hypotenuse is C. Now let's simplify this equation by finding out what X is. And this needs to be squared, by the way. 17 squared is 17 times 17, or 289. And that's equal to 11 squared, or 11 times 11, that's 121, plus X squared. And now to get X squared by itself, I need to subtract 121 on both sides. So here, this is X squared on the right. 289 minus 121 is 168. And that's equal to X squared. Okay, so if I take the square root on both sides to get X by itself, square root of X squared would be X. 168 is not a perfect square, so I need to find the largest perfect square that goes into 168. That'll have to be 4, because 4 goes into 168 42 times. And then the square root of 4 will be 2. And we'll leave that 42 underneath the radical since it's not a perfect square. So that means that the height above the ground to the top of the ladder, that's this length, will have to be 2 square root of 42. And this will be in feet, by the way. Because I'm sure in the homework they're going to ask for the unit of measurement, which will be in feet. 2 square roots of 42 feet. Okay. All right, here's another example. In the figure, 2 poles are 15 meters and 20 meters high. A cable 15 meters long joins the top of the poles. And I want to find the distance between the 2 poles. In other words, I want to find that distance from this pole on the left to this pole on the right. In other words, what would that length be? We have to use a different pen. There we go. That's this length right here is what we're trying to find. And I will label that as, of course, X. I need to find out what this length is going to be equal to. So this length plus this length right here has a total of 20 meters. Well, I also know something else here. This figure down here is a rectangle. And in a rectangle, opposite sides are going to be equal in measure. So if this length is 15, then that means that this length coming this way must be 15 as well. In this case, 15 meters. Well, if that's 15 meters and the whole thing is 20, then this other length right here, if I subtract 15 from 20, that would be 5 meters. Okay, has to be 5 meters. All right, so let me focus on the triangle that's going to be up here in green, because that's the one I'm going to be looking at using the Pythagorean theorem. Again, that's going to be c squared is equal to a squared plus b squared. The c is the hypotenuse. This is your hypotenuse right here, since it's the side opposite the right angle here. In this case, it's going to be 15 meters. So that c is going to be 15, and that's squared is equal to this side. I'm going to let this be a, which is 5 meters. So it'd be 5 squared plus b is what I'm trying to find. That's this length right here, which I labeled as x, and that's going to be squared. All right, so let's simplify this. 15 squared is 15 times 15, or 225. That's equal to 5 squared, that's 25, plus x squared. Then if I subtract 25 on both sides of this equation, that would mean x squared is equal to 25 from 225, that will be 200. And now to solve for x, since I'm squaring the x, the opposite of that would be to take the square root on both sides. Square root of x squared would be x. Now, I want you to pay close attention to what my math lab wants for an answer. For this type of problem, they want this as a decimal to 1 decimal place. So you do have to use your calculator to do this problem to come up with a decimal approximation for the square root of 200. So if I do on my calculator second x squared for the square root and then 200, hit enter. Let's say the 1 decimal place, that would be 14.1. Okay. And this will be in meters, since our units that we're dealing with in this problem deal with meters. So to 1 decimal place, the distance between those 2 poles here would be 14.1 meters. Okay. Okay. Now you want to pay close attention to what they want. They might want the decimal value. They might also want the exact value as well. Okay, on the next page is some more examples dealing with the Pythagorean theorem and using it to come up with the area of the figures for parts A and B below. Okay. In my case, I'm probably left off part B in this case. I might need to do part 2 of this video to find out what part B is. Okay. Or let me pull up the homework that I printed off that I used here in this video. Okay, we'll just deal with part A for now. Okay, and I think part B is later on in these notes as well. So let's just deal with part A. Okay. Now in part A, we got this parallelogram right here. And we want to find, let's say, find the area. Well, of course, in the parallelogram, if you recall, the area of a parallelogram is always going to be the base times the height. We already see what the base is. If I add 15 feet and 15 feet together, I would end up with a total of 30 feet. That would be the base. The problem here is I don't know the height. I don't know what this is. But I can use the Pythagorean theorem to find out what the height is. So let me focus on this triangle that I'm gonna trace in green, because I know the length of this side is 15 feet. And I know the length of this side, that's the hypotenuse, which is going to be 25 feet. I need to find out what h is. That's that height of this parallelogram. So in this case here, let's use the Pythagorean theorem, which is, of course, c squared is equal to a squared plus b squared. Okay, so here the c, which is the hypotenuse, that's 25 feet. Or I'll just say 25, and that's going to be squared, is equal to, this will be a, that's 15 feet. So it'll be 15, and that's squared. The b is going to be that h. So I'll substitute that with the h and then square. All right, in this case here, let's simplify. 25 squared will be 625 is equal to 15 squared, that's 225, plus h, and then that's going to be squared. Now to get h squared by itself, I'm going to subtract 225 on both sides. So this will be 400 is equal to h squared. And then we take the square root on both sides to get h by itself. So that means h is equal to square root of 400 would be 20. So that means that the height of this parallelogram is 20 feet. That's going to be your height, 20 feet. And now we can use that area is equal to base times height formula for the area of a parallelogram. So now my base is this 30 feet going straight across from 15 plus 15. So this is 30 feet for the base. The height going straight up and down, that's 20 feet, which is what we found out what h was using the Pythagorean theorem. So 30 feet times 20 feet will be 600. And it's going to be in square feet because area, if you recall, is always in square units. So here, the area of that parallelogram is 600 square feet. Okay. All right, let's look at homework example number 5. Let's say I want to find the area of the rhombus is given to the right, and there are two parts, parts A and B. Let's look at part A. Now here we have a rhombus. Now notice that it's split into 4 equal triangles here. 4 equal triangles. And if we were to use the formula for finding the area of any one triangle, that would be 1/2 the base times the height. I can see that this base is 2 centimeters. I don't know what the height is. So this is where the Pythagorean theorem comes in. All right. And notice that these two diagonals intersect at a right angle. So the one on the upper right is a right triangle. In fact, these are all 4 equal right triangles. So let's use the Pythagorean theorem first. That's going to be c squared is equal to a squared plus b squared. The c is your hypotenuse. That's your 15. So it'd be 15 squared is equal to, this length will be a. That's 2 centimeters. 2 centimeters. 2 squared. Plus b is what we're trying to find, which is your h. So it'd be h squared. Now let's simplify this. 15 squared is 225. It's equal to 2 squared, that's 4, plus h, and that will be squared. Now if I subtract 4 on both sides to get the h squared by itself, that would mean h squared here would be 221. And then to solve for h, we take the square root on both sides. So here, this will be h. That 221, I'm not going to be able to take the square root of that. It's not a perfect square. So we're going to leave that as the square root of 221. So that's what h is. Now, since this, and I'm going to outline this in green again, since this triangle, this right here is a triangle, we're going to use the formula for finding the area of a triangle, which is, of course, 1/2 the base times the height. So I'm going to bring down the 1/2. The base here is your 2 centimeters. So this will be 2 times. H will be the square root of 221. And half of 2 will be 1. And then 1 times the square root of 221 would just be the square root of 221. That's only the area for one of these triangles here. But notice we got 4 equal triangles. So that means, I'm going to say the total area, that's going to be 4 times the area of one triangle. 4 times the square root of 221, which will just be 4 square roots of 221. And this will be in square centimeters, because area is always in square units. And we're given the centimeters, the length in centimeters, so the area will have to be in square centimeters. So this is part A that I just did, this one. Now for part B, this time is 1 centimeter for this side, and I still have 15 centimeters here. So I'm outlining that triangle. And again, I'll have to use the Pythagorean theorem to find out the length of this height, which is going to be h. Okay, so let me pull this up. So this is c squared is equal to a squared plus b squared. Let's see, the c is your hypotenuse, that's the 15 centimeters. So this will be 15 squared. Is equal to a. Now this time it's 1. So it'll be 1 squared plus b, which is your h, and that's squared. Now 15 squared is 15 times 15, that's 225, equaling to 1 squared, which is 1, plus h squared. Now, to get h squared by itself, I subtract 1 on both sides. So that means that h squared is equal to 224. And then take the square root on both sides. This will be h is equal to, now this time I'm going to try to find the largest perfect square that goes into 224. Okay, the largest perfect square that goes into 224. And in this case here, let's see. Well, 224 is divisible by 16. Okay, so I'm going to be using 16 times. Well, 16 went into 224 14 times. Okay. So you have to find the largest perfect square that goes into 224, because I know you have to start with 225 and just keep going until you get to, in this case, 16. All right, so here, h would be equal to square root of 16 is 4. 14 is not a perfect square, so it'd be 4 times the square root of 14. And that's what h is going to be equal to. Okay, so now I have a triangle. Let's find the area of one of these triangles. Using this formula, a is equal to 1/2 the base times the height. Well, here the base here is 1 centimeter. You got 1 centimeter. So it'd be 1/2 of 1 times h, which is 4 square roots of 14. Let's see, 1/2 of 1 is 1/2. Half of 14 is 2. So it'd be 2 square roots of 14. That's only the area of a single triangle. We got 4 equal triangles. So that means we need to find that total area by multiplying 4 times 2 square roots of 14. Well, let's do 4 times 2. That's going to be 8 square roots of 14. And this is in square centimeters. All right, so in this case here, the area of this whole rhombus is 8 square roots of 14 square centimeters. Okay. Let's do one more of these real-life problems here that use the Pythagorean theorem. A company wants to lay a string of buoys across a lake. To find the length of the lake, they made the given measurements. What is the length of the lake? Okay, so here's the right triangle. This has to be your hypotenuse, which is your C. And this is A. And this will have to be B, because B is what we're trying to find. So using that Pythagorean theorem, we're going to have C squared is equal to A squared plus B squared. Your C is your hypotenuse. That's 39 feet. So it'd be 39 squared is equal to, this is your length A, that's 23 feet. So it'd be 23 squared plus B is what we're trying to find, so it'd be B squared. All right, in this case here, 39 squared is 1521, equally to 23 squared. That'd be 529 plus B squared. And now to get B squared by itself, we're adding 529, so I need to subtract 529 on both sides. So that means B squared is equal to 992. Okay, so B squared is equal to 992. And I will go ahead and take the square root on both sides to get B by itself. Okay, so here they want this as a decimal. Okay, so when I did the square root of 992, I get 31.496, but to one decimal place, it would be approximately 31.5, and it'll be 31.5 feet. So again, you just have to pay close attention to what my math lab wants you to give as an answer, either as an exact answer using radicals or as a decimal, approximating to whatever number of decimal places that they ask for. Okay. All right, so much with the Pythagorean theorem. I gave a lot of examples here. Let's look at special right triangles. Special right triangles. All right, an isosceles right triangle has two legs of equal length and two 45-degree angles, as you can see in this illustration here. Any such triangle is called a 45, 45, 90 right triangle. Okay, so as you can see here, the lengths here are the legs of one, and the angles here are both 45 degrees, which makes the hypotenuse the square root of 2. Again, you can use the Pythagorean theorem of c squared is equal to a squared plus b squared, and you will see that the length of that hypotenuse will be the square root of 2. Okay, now for this one, this length of this side be s, and this side also is s. Okay, so here, if you did s squared plus s squared, that would be 2s squared. If you take the square root of s squared, it'll just be s, but you're going to have the 2 underneath the radical. So the length of this hypotenuse will be s times the square root of 2, which introduces us to this relationship. In an isosceles right triangle with the length of each leg being a, the hypotenuse has the length of a square root of 2. Okay, so if you're given either one of these legs in an isosceles right triangle, the hypotenuse will be the length of that leg multiplied by the square root of 2. All right. Now, the next relationship is the 30, 60, 90 triangle. Okay. So the figure here, as you can see here, shows that a 30-degree, 60-degree, 90-degree triangle has half the area of an equilateral triangle. So here's an equilateral triangle where all the lengths of each side are equal. But here, if you draw a altitude, which is going to be perpendicular to the opposite side, that means here, this will be your midpoint. From here to point B, that's going to be length S. And this right here, from A to B, that's what 2 times X. Okay. And now if you were to use your Pythagorean theorem, you're going to see that the length of this altitude would be S times the square root of 3. So in a 30, 60, 90 triangle, which is this theorem here, the length of the hypotenuse is twice the length of the leg opposite the 30-degree angle. So here's the 30-degree angle here. This length, and here's the opposite side right here of that 30-degree angle. That's S. The length of this hypotenuse will be 2 times the length of this side right here. If this is S, your hypotenuse will have to be 2 times S. And then you got a leg, the length of the leg being opposite the 60-degree angle. So this is your 60-degree angle right here. That's in black. This leg right here opposite that will always be the square root of 3 times the length of the shorter leg. So this short leg here is S, then this length opposite that 60-degree angle will be S times the square root of 3. Okay, now I'm going to try to use that relationship with this example here. Let's say I want to find the area of the figure below. Well, actually, I'm going to try to use the one that's going to be the 45, 45, 90 relationship, because by looking at this, if I was to look at this, Take a look. Those sides are equal. Okay, those sides are going to be equal in measure. Or better yet, well, I thought I could use it that way, but I don't think I will. Okay, let's take a look at the left side of that triangle. I might have just use the ever so popular Pythagorean theorem. I'm just going to outline this triangle on the left-hand side. This side is 60. I know the hypotenuse is 70. Let's try to find out what x is. So if I know what x is, I can easily find out what this length is, because it's also going to be the same as well. Because this altitude is separating this side into two equal parts. So let's go ahead and use the Pythagorean theorem. Just to be on the safe side, c squared is equal to a squared plus b squared. Your c is your hypotenuse, that's 70, and that's squared, equals to, I'm going to let a be the x, so that'd be x squared, plus this side here is 60, and that's squared. Now 70 and u squared would be 4,900. That's equal to x, and that's squared, plus 60 squared is 3,600. Now if we subtract 3,600 on both sides, that would mean this will be 1,300 equaling to x squared. And then we take the square root on both sides. This will be x. Now the largest perfect square that goes into 1,300, I know, will have to be 100. So this is 100 times 13. And 100 is a perfect square, so the square root of 100 is 10, multiplied by the square root of 13, and that's going to be x. So this is 10 square roots of 13, and this is going to be equal to 10 square roots of 13 as well. So if I add those two together, 10 square roots of 13 plus another 10 square roots of 13, that's 20 square roots of 13. Okay, so now we can find the area of that figure below. And of course, the area of a triangle is 1/2 the base times the height. Okay, so here's your base, which is going to be 20 times the square root of 13 times the height, which is 60. And if I take half of 20, that will be 10. 10 times 60 will be 600 times the square root of 13 square feet. Okay. Okay, I did think that I was able to use either the 45-45-90 relationship, but in this case here, that's probably not going to be that situation. Okay. All right. Next page is some more examples dealing with the Pythagorean theorem. Okay. Okay, so for each of the following, solve the unknowns. Solve for the unknowns here. So here we're going to be solving for x, and we're going to be solving for y. Okay. Let's look at part A. we want to find out what x is. Well, let's look at the whole triangle outlined in green. So here, this is a right triangle. Okay, I know this length and I know this length. I don't know the hypotenuse. That's the opposite side of the side opposite that right angle. So let's find out what that's going to be equal to in this case. All right, so here I'm going to use c squared is equal to a squared plus b squared. And in this case, the c is your hypotenuse, which is labeled as x. That's going to be squared. That's equal to, I'm going to let this side be a, that's 12, and that's squared, plus this side is labeled as 12 square root of 3. That whole thing will be squared. All right, the x in u squared would be x squared equals 12 squared, or 12 times 12, that's 144, plus 12 squared again, that's 144, times the square root of 3 and u squared, that wipes out the radical, you're left with 3. And then I'm going to do 144 times 3, which is 432. 432 plus 144 will give me 576. And if I take the square root on both sides, that means x is equal to, if I take the square root of 576, that would give me an answer of 24. So in this case here, x in this case will be 24. Now I need to find out what y is. Okay, so we're going to be dealing with this triangle right here. Now, in this case, we can use the 30, 60, 90 relationship that I talked about earlier. We can use that 30, 60, 90 relationship. And I'm going to show you how this is going to be done. All right, to find out, I know the hypotenuse is 12. This leg right here is the short leg. That length is always going to be 1/2 the hypotenuse. So in this case here, and unfortunately I don't have enough room here, the short leg equals 1/2 the hypotenuse. I'm going to abbreviate here. So that means if I take 1/2 of 12, that would give me 6. So this length here is going to be 6. And that's what's going to help me find out what y is. Because the y is the long leg. Okay? And that's going to be the square root of 3 times the short leg. And that short leg was 6, so it'll be the square root of 3 times 6. The best way to write that would be 6 square roots of 3. Okay, so that's what y is. That's this longer leg in that right triangle. And a quicker way I could have gotten that was, since this bigger triangle was a 30, 60, 90 triangle as well, I could have doubled this 12 to get this length right here, which is 24. Okay. All right, now let's look at part B. Part B is that 45, 45, 90 right triangle. Okay. And here I want to find out what x is, and I want to find out what y is. All right, so to find out what x is, in this case, your x is your hypotenuse, and the hypotenuse is always going to be the square root of 2 times one of the legs here, okay? Here, if this leg is the square root of 3 over 2, this has to be equal to the square root of 3 over 2 as well, because those two legs have to be equal, since these angles are equal as well. And one of the legs is the square root of 2, so I have square root of 2 times 3 square roots of 2. Now I'm going to work this out, bring down the 3. The square root of 2 times the square root of 2, I can simplify what's underneath that radical. That's going to be 4. And the square root of 4 is 2, so I have 3 times 2, which is 6. So x in this case will be 6. Okay, now notice that this length here is the altitude, and it separates this side into 2 equal parts. So this side and this side are equal in measure. So if the whole thing is 6, then this length is 3, and this length has to be 3. Well, now I'm going to focus on this triangle right here. This 2 is a 45, 45 right triangle, where this length and this length right here is equal. So if this length is 3, then y must be 3. So your y has to be 3. So x is 6 and y is equal to 3. So this is one of those 45, 45, 90 relationships that I use here in part B, but in part A, I use the 30, 60, 90 relationship to get the answers. Okay, now let's talk about the converse of the Pythagorean theorem. Let's say a triangle ABC is a triangle with sides of lengths A, B, and C, such that C squared is equal to A squared plus B squared. Then triangle ABC is a right triangle with the right angle opposite the side of length C. In other words, you'll be given 3 lengths. You want to use the Pythagorean theorem to determine whether or not you have a right triangle. In other words, when you use the Pythagorean theorem, the left side must be equal to the right side, like in this homework example number 9. You'll want to determine whether the given numbers represent the lengths of sides of a right triangle. And we got 42, 44, and 8. Now we have to choose our hypotenuse, which is going to be C, very carefully. The hypotenuse is the longest side. So the longest side of these 3 is 44. So C will have to be 44. And we can let A be 42 and B be 8. So now we're going to use that Pythagorean theorem. C squared is equal to A squared plus B squared. And in this case here, your C is going to be 44. And that's squared. Your A is 42. That 2 is squared plus B, which is 8, and that's squared. 44 squared would be 1936. And I want to know if that's going to equal to the square of 42, which is 1764, plus 8 squared, which is 64. So if I add 1764 to 64, that's going to give me 1828. And does 1936 equal to 1828? And the answer to that question is a simple no. Okay. So the numbers 42, 44, and 48 do not represent the lengths of the sides of a right triangle, okay? Because the left side must equal to the right side in order for you to have a right triangle in this case. All right, so much for that. Let's move on to something different called the distance formula. Okay. Now, this is actually derived from the Pythagorean theorem as well. So if you had something like this, let's say we had 2 points A and B. Okay. And then we drew a horizontal line from A and then a vertical line from B and connect those two to get point C. Okay. So the horizontal distance going this way will be from x2 minus x1. The vertical distance going from B to C would be y2 minus y1. Okay. And then we use that Pythagorean theorem to come up with our distance formula. And for the sake of time, I'm not going to derive that distance formula for you, but I'm just going to give it to you as is. The distance between 2 points A, which is x1, y1, and B, which is x2, y2, is given by AB is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, so we're going to apply that distance formula to these problems here. For each of the following pairs of points, we want to find the length of line segment AB. And in part A, we got A, which is the ordered pair 0, 1, and B with the ordered pair 0, 4. And I want to find the length of that. Okay, so here we're going to use that distance formula. A, which is 0, 1, and B, which is 0, 4. This first order pair, x1 will be 0, y1 will be 1. The second order pair, x2 will be 0, y2 will be 4. So that line segment, that distance will be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So here, in this case here, x2 minus x1, that's 0 minus 0. So I got the square root of 0 minus 0, and that's squared, plus y2 minus y1, that'd be 4 minus 1 quantity squared. If I simplify this, 0 minus 0 is 0. That will be squared, plus 4 minus 1, which is 3. That will be squared. Of course, square the 0, that's going to be 0, plus 3 squared, or 3 times 3, which is 9. 0 plus 9 will be 9, and the square root of 9 is 3. So the distance from A to B using that distance formula would be 3. Or I should say the length of AB is 3. All right, part B. Let's say we got A with the ordered pair 0, 6. A with the ordered pair 0, 6. B with the ordered pair 8, 0. And the length of AB. Now I'm not going to rewrite that formula. This will be x1, that's y1. The second order pair will be x2, y2. So x2 minus x1 is 8 minus 0. That quantity is squared, plus y2, which is 0, minus y1, which is 6. And that quantity will be squared. So I'm using this distance formula, just substituting x1 x2, y1, y2. Simplify, and notice I'm bringing down the radical, or that square root symbol. 8 minus 0 is 8, and that's squared, plus 0 minus 6 would be negative 6, and that's squared. 8 squared, or 8 times 8, is 64, plus negative 6 and u squared, that's negative 6 times negative 6, that's 36. So 64 plus 36 is 100, and the square root of 100 is 10. All right, so the distance between those 2 points, A and B, or the length of those 2 points will be 10. Part C. Here we got A with the ordered pair -6 and 25, and B -9, 5. So using that distance formula, I'm going to have the square root of, and this will be x1, y1 for the first order pair, x2, y2 for the second order pair, x2 minus x1. This will be -9 minus -6, and that quantity will be squared. You're always subtracting. You're always going to subtract your x's, and then plus, you're always going to subtract your y's, 5 minus 25. And that 2 will be squared. Now, square root of -9 minus a -6. That would be -3, and that's squared. Plus 5 minus 25 will be -20. That 2 will be squared. -3 squared is -3 times -3, that's 9. Plus -20 squared will be -20 times -20. That's 400. Add 9 to the 400, you'll get the square root of 409. And that would be as far as I would go with that problem, because there's no way I'm going to simplify that in terms of radicals here. So it just have to be the square root of 409. Okay. So here they want the exact answer for that problem. Okay. So that's how the distance formula is used, but we can use that to develop the equation of a circle. If you recall that a circle is a set of all points in a given plane equidistant from a given point, which is the center. Let's say we let x and y, or xy, be any point on the circle with the center at the origin 0, 0. So here, so xy is up here, by the way, as you're going. Let's say x units to the right and y units up. From the center of the circle to the point on that circle, that is your radius. And of course, from the distance formula, or pretty much from the Pythagorean theorem, it will be this. R is equal to the square root of x squared plus y squared. Now, if we were to square both sides to eliminate the radical, as I'm about to do right here, when you square a radical or square a square root, the square root symbol is gone. You're left with x squared plus y squared. And then that's going to be equal to, on the left side, r squared. So this is exactly the equation of the circle with the center at the origin, which is what we have right here. That's this theorem. The equation of a circle with the center at the origin and radius r is going to be this: x squared plus y squared equals to r squared. Okay, now that's only for the center, for the circle being at the center, where the center is at the origin. But let's say the center is someplace else other than the origin, like this one right here. Let's say the center is at some h comma k, and r is the radius as shown below. We can also use that distance formula as well. And here that distance formula would be from that the r, which is your radius, is equal to the square root of x minus h quantity squared. That's going to be x2 minus x1, and that quantity squared, plus y2 minus y1, y minus k, quantity squared. All right, but what happens if I square both sides? That will wipe out this radical. When I square the square root, that square root symbol is going to be gone. It's going to be, you're going to be left with what's underneath it, which is x minus h, quantity squared, plus y minus k, quantity squared, and that's going to be equal to r squared. And that derives this other equation of the circle, where the center this time is at h comma k. Okay. So an equation of the circle with center h comma k and radius of r is going to be x minus h quantity squared plus y minus k quantity squared equals r squared. Now, the next page are some examples here where, excuse me, where in this case here, we're going to first give the center and radius in each of the following circles. Like in part A, we have the equation x squared plus y squared is equal to 4. Not 14. Where I got that from? Just 4. All right, notice we just have x squared plus y squared. That means that the center of this circle is at the origin. And the origin is the ordered pair 0, 0. So the center is at 0, 0. Now for the radius, that 4 right there is r squared. But to find the radius, you always take the square root of that. So the square root of 4 is 2. So the center is at the origin 0, 0. The radius is 2. Right now, part B. Here we got x minus 3 quantity squared plus y minus 2 quantity squared is equal to 36. And here I want to find the center and the radius of that circle. Well, to find the center, notice that it's not at the origin because you've got a 3 and a 2 right here. Now, the way you're going to identify that center is this, because it is written in this form, as you can see here, x minus h quantity squared plus y minus k quantity squared equaling to r squared. What I would do here, take the opposite sign of each one of these. Since both of these are minus, the opposite of that would be a positive. So the 3 has to be positive and the 2 has to be positive. Now, if one of them was a plus, then you take the opposite of the plus, which is a negative. Okay, so the center of that circle would be 3, 2. Now for the radius, that 36 represents r squared, not r. R squared, that's 36. To find out what r is, you take the square root of 36, which is 6. So the radius of the circle is 6. The center is at the ordered pair 3, 2. So with your center, you have to take the opposite sign for the h and for the k. Here's another example, one where the center is not at the origin. X plus 1 quantity squared plus y minus 1 quantity squared is equal to 3. And again, I want the center and the radius. All right, let's look at this here. Here's your H and here's your K. Each one, we take the opposite sign. This is a +1, so the H will have to be -1. And this is -1. The opposite sign of that will have to be a +1. Okay, so the center is the ordered pair -1, 1. Now for the radius, that 3 represents r squared. So r squared is equal to 3. And to get r by itself, you take the square root of that. So it'd be square root of 3. And we'll just leave it as that. So the center of that circle will be at -1, 1. The radius of the circle is the square root of 3. Now part D. Let's say we got x squared plus y plus 5 quantity squared equals 64. And again, I'm going to find the center of that circle and the radius. Okay. Now for the x squared, we can write that as, do this off to the side, x minus 0 quantity squared, and then plus y plus 5 quantity squared equals 64. That's another way of writing that. And now you can see that the x coordinate of your center will be 0. The y coordinate, we take the opposite sign as well. So the opposite of 5 will be -5. So 0, -5 will be the center of that circle. Now for the radius, that 64 is r squared. So r squared is 64. And to find out what r is, you take the square root of 64. And the square root of 64 is 8. So the center is at 0, -5. The radius is going to be at 8. Okay, so that's how you identify the center and the radius for each of the following circles here. All right, the last example in this video is to find the equation of a circle with the given center and radius. So in part A, we're given that the center of that circle is -5, 10. The radius, now I'm going to label this as r, as 7. Okay. Since the center is not at the origin, we're going to use this. The x minus h quantity squared plus y minus k quantity squared is equal to r squared. So in this case here, let me go ahead and write that down. X minus h quantity squared plus y minus k quantity squared is equal to r squared. In this case, your center, h is -5 and k is 10, and r is going to be 7. So we need to just substitute the h, the k, and the r in that formula. So it'd be x minus h, which is -5, and that's squared, plus y minus k, which is 10, and that's going to be squared, is equal to r, which is 7, and that's going to be squared. Now, x minus a -5, I'll rewrite that as x plus 5, and that's squared, plus y minus 10, and that will be squared, equals 7 squared, or 7 times 7, which is 49. So this would be the standard form of the equation of the circle with a radius of 7 and a center at -5, 10. X plus 5 quantity squared plus y minus 10 quantity squared equals 49. And part B. Let's say we have a center of -8 and 1 with a radius, which I'll label as R, as the square root of 7. And that 8 will be your H, your K will be 1. And I want the equation of the circle with that center and that given radius. So again, I'm going to use the x minus h quantity squared plus y minus k quantity squared is equal to r squared. So here, bring down the x minus h, which is -8. So I get x minus -8, and that's squared, plus y minus k, which is 1, and that's squared, and that's equal to, the r is the square root of 7. It's going to be squared. Okay, so x minus a -8, that's going to be x plus 8, quantity squared, plus y minus 1, quantity squared. Square root of 7, you turn around and square it, wipes out that radical, so you'll end up with 7. So the equation of the circle with the center at -8, 1, and a radius at being the square root of -7 would be x plus 8 quantity squared plus y minus 1 quantity squared is equal to 7. Okay, now keep in mind your equations have to have x and y in it. Okay, and keep in mind that the center, h, is your first coordinate, your k is your second coordinate. All right, so that does conclude this video on section 13-3. And that's going to be dealing with, in this case, the Pythagorean theorem, distance formula, and equation of a circle. All right, good luck on the homework problems in my math lab, and feel free to contact me if you have any questions about what's presented in this video, as well as the homework for this section in my math lab.